Welcome back everybody. This is the second part in terms of data representation, topic 1.1 under the Cambridge iGCSE Computer Science course. We're following 1.1.1 binary systems, and this is part B, which is converting positive denary integers into binary and positive binary integers back into denary. So this covers Cambridge iGCSE 9-1, which is course code 0984, or the A starter G code, which is 0478. Okay, we're still in section 1, very beginning of section 1. We're on the theory of computer science, as you can see here, and we're looking at 1.1 data representation, as I mentioned earlier, 1.1.1, which is binary systems. We're then going to cover hexadecimal and data storage in this particular topic. So there you can see there, converting positive denary integers into binary, we looked at that last time, and converting positive binary integers back into denary. Okay, so going back to the last video, video A, I gave you this number, 100111010. This is base 2, okay, and it's a binary number. Now all I did with this, and all we need to do when we're converting binary numbers into decimal, into denary, is to pop these numbers into a little table like this. Now I do recommend, and I've said this before, I do recommend you creating one of these little tables, or certainly these headers, 1, 2, 4, 8, 16, 32, 64 and 1 to 8. That's 8 numbers there, or 8 potential numbers, so it would be 8-bit, which would be 1 byte. Okay, so we pop those numbers in, and as we did last time, we have one lot of 128, one lot of 16, one lot of 8, and one lot of 2. So if we add all those numbers together, we have 128 plus 16 plus 8 plus 2, which gives us a grand total of 154 in base 10 in denary. Okay. So I'm going to do the same here, but now I've got 207, so I'm going to use a reverse method of doing this. So I've got 207, and I want to pop this into the same table. So I'm going to be placing ones and zeros into this table here. So if I put a 1 in the 128 column, yeah, I then need to take that away from 207. So 207 take away 128 would leave us 79, a remainder of 79. So a carry on, I would put another 1 in the 64 column. So now I've got one lot of 128, one lot of 64, which would leave me a total of 15 left. Now 32 doesn't go into 15, so we'd put a 0 in that column. 16 again doesn't go into 15, so we would put a 0 in that column. Okay, but then we've got 15 left over. Now 15 is basically 8 plus 4 plus 2 plus 1, so we would put ones in all of these columns. Okay, so the number there is 11001111 in binary. Okay, now that's the easy method. Okay, a simple question of sort of subtracting, taking away, finding the remainder once we've removed these headers, these numbers, from the value we're trying to find. Okay, now method 2 works in a slightly different way. We're going to start off with the same number again, 207, but this time we're going to successively divide the number by 2, and we're looking for the remainder values. Okay, so anything that ends in an odd number will generally return a 1. Anything that ends in an even number should give us a 0. Okay, so we start by writing down the number 207, and we're going to divide this by 2. Okay, so we divide it by 2, it gives us 103, which is basically 2 lots of 103 would be 206, which means we've got 1 left over, so that would be remainder 1. Okay, so we carry on down and divide 103 by 2, and again we've got an odd number, so it would be 51. Yeah, remainder 1. Carry on down again. Of course, 2 lots of 25 would equal 50, so we've got remainder 1 there. Yeah. Again, 2 lots of 12 equals 24, remainder 1. So we've got 4 remainder 1s so far. Obviously, 12's an even number. 6 is an even number. So remainder 0. 6 goes into 12 twice. 3 goes into 6 twice. But we've got an odd number here, so I can feel we should have a remainder 1 coming on. And then we can't put the 2 into the 1, so for the very final number would again give us a 1. Now this is where the problem lies, and this is why I'm saying that this potentially is a difficult method to remember, in the sense that you've got to read the number upside down. You've got to go from bottom to top when you return this number. So when we do that, we will end up with a number of 1 1 0 0 1 1 1 1, which is the same as the method of when we use method 1. But I don't know whether you'll agree. Some of you might find that really, really easy. Others, like myself, might want to stick with the previous version. But they're both there, and they're both in the textbook, so that's why I am teaching you them. Okay, I'm going to give you a little exercise now. I'm going to take a couple of binary numbers, a couple of bytes, and a couple of denary numbers, and I want you to convert between the two. So the binary numbers I want you to convert into decimal or denary, and the denary numbers I want you to convert into binary. If you want to pause the video, questions, converting the binary, we should have got 134 and 204, and with the denary numbers we should have got 1 0 1 0 0 0 0 1 1. And for 235, we should have got 1 1 1 0 1 0 1 1. Now with the 67, of course we didn't need all 8 numbers. We could have omitted the first 0, but I would recommend getting into the habit of putting those zeros in, because generally speaking, if in an exam, and I've seen these questions pop up time and again, whereby it will ask you to write the number as a byte. Okay, so always write down, even if it's got 3 zeros at the front, always write those zeros in. Okay, next time we will be moving on to demonstrate that you can show an understanding of the concept of a byte and how the byte is used to measure memory sizes. So in that respect, we'll be looking at a byte, kilobytes, megabytes, gigabytes, terabytes, and how they relate to each other and what we use them to measure such things as hard disk space, RAM, and so on and so forth. Obviously, the objective is to get you as close to it a 9 or an A star in this subject. So please subscribe, keep watching, and any questions, please add those to the comments below, and I will do my best to answer. Thank you very much indeed. See you next time.